Okay, let's get started. Remind me, I want to take roll between the two lectures. Okay, the readings here are a three-part series of articles I did for my column at Baseline a decade ago on metrics. Metrics are one of the great, that's what I'm looking for. No, I was going to say pitfalls. Evils isn't bad, based on how they're used. Metrics simply means something you measure. The problem is that you have organizations that want to collect project metrics, and too often, at best, the metrics are useless, and at worst, they are distorting and destructive. Part of the issue here, and we'll get into this more in a slide or two, is that the usual use of a project metric is, there are two big uses. One is they want to punish you. Possibly reward you, but it's like, you're not doing this right. You know, we expected 100 lines of code from you this week and you only gave 90. You know, we're upset with you. Seriously, there are organizations that do stuff like that. The other issue, it's like, okay, based on these metrics, we know when the product's going to ship. Now stop and think about all the pain that you've gone through this week trying to estimate with what you know. That's the same problem with metrics. What metrics do you have that really tell you how close you are to shipping? The big problem is most metrics used out there are not very useful. One of the worst, which I would like to think no one tries to use anymore, and I would almost certainly be wrong, is lines of code. Well, we estimate this program is going to be 100,000 lines of code. We've written 50,000 lines of code, therefore we're half done. That's misleading on so many levels, starting with the fact that good software engineering involves refactoring. Refactoring usually involves reducing the number of lines of code. You're saying, oh, we are doing the same similar thing in these three places. We're going to make one object or one subroutine or one API or one microservice and put it in that, and suddenly you've just cut out. You've replaced 3 chunks of code with 1 chunk of code. Yes?
Has anyone ever tried to talk to management who cares about how much you write and say, have you ever tried to write an essay and then have to revise it so many times and try to cut things out and stuff, and the amount of text you write doesn't matter?
Short answer is yes. People have tried to talk to management like that. Slightly longer answer is, and largely management doesn't care. Management wants, this gets back to what we've already talked about, and we'll talk about again. There is this underlying sense that programming is like digging ditches. You know? Get 10 people, they've got to dig a ditch a certain size, each person can dig so much per hour, therefore it's going to take this many hours to dig the ditch. Get twice as many people, we'll dig in half the time. The management wants to measure things because it gives them comfort in a very uncertain world. But it doesn't, the problem is most of what they measure is, yes?
Just on that, one of the things PeopleWare talks about is that management is often inherently distrustful of programmers.
Oh, yes, yes.
And it's interesting why a metric like lines of code would be used, because that's something you can easily say, oh, someone's actually been writing code, and so I can say that they're writing code, rather than just, like, part 3 gets into browsing Facebook or email or something like that, that there's this worry that people aren't actually working.
Yes. The worry that someone somewhere is having fun. We don't want you to have fun. We want you to crank out so many lines of code per week.
It's some wizard sitting in his office staring off into space with his feet on his desk.
Well, yeah, and I have been that lizard. your point is actually very important. There tends to be mistrust between management and engineers because too often management does not understand the software process. Frankly, there are often managers who are promoted up out of software engineering who aren't necessarily good coders who also don't understand the process, or they look for the easy answers. Now, for a metric, a project metric to be useful and meaningful, it needs to have 3 characteristics. It has to be informative or predictive. That is, it tells you something important and or when you will deliver. It has to be objective. That means if you have 2 different people who are basically trying to assess the same metric, they should come up with the same answer. Stop. Here's a thought experiment. Imagine your teams as they currently constitute. Imagine 3 weeks from now, if I took each member of your team individually and said, how close do you think you're to being done? Give me a percentage. Do you think I'd get the same percentage answer from everyone?
Yeah, we're going to collaborate on that.
Yeah, you are now. You've been warned.
We're going to
But-
quit the books.
But yeah, and we're going to get to that one too. It has to be objective and it should be automated. If a metric requires human effort, and I'm talking about significant human effort, then it usually will be abandoned or done poorly. This is why lines of code is so popular. There are all sorts of little scripts and tools and commands and so on. It's like, yeah, give me the number of lines of code for this this folder. And bam, there it is. But it's not informative, it's not predictive. It is objective, it is automated. It's just not useful. This point, almost all major metrics used in IT projects lack one or more of those qualities. The ones that are objective and automated are almost always not informative or useful. The ones that are actually informative and useful are usually not automated. They require some judgment or evaluation. Metrics laws. And this gets to your point. Jerry Weinberg's law of metrics. That which gets measured gets fudged. I've already mentioned one of the classic cases. A company saying we're gonna establish a bug bounty. I mean, this happened multiple times. Some company thinks they have a bright idea. We're gonna pay our QA people $50 for every bug they close until we ship.
I see no problem with this.
And then you have coders who introduce new bugs, and you have QA people who find them and fix them, and they split this $50. It's human nature. The metric law of 90s. I've already quoted this. The first 90% of the project takes 90% of the schedule. The remaining 10% takes the other 90% of the schedule. This is scarily true. This is not original with me. You'll find this in the industry literature. It's because we sort of have this, well, we've done this, we've done this, we've got our user interface, we've got these game levels, and you can do this, and it's fine, and all it requires for us to be done is to do this, this, and this. And suddenly you find those are the 3 hardest problems in what you're doing. And things stretch out for weeks and months trying to get those solved. Metric law of least resistance. More human effort that is non-automated a metric is, the less often and the less accurately it will be calculated until it's abandoned or ignored altogether. If it's easy, it'll be done. This is the old joke about the drunk who's down on the ground and hands his knee under a lamppost to them. Someone says, what are you doing? He says, I'm looking for my car keys. He said, where'd you lose them? He says, over there. He said, why are you looking here? Well, the light's better. You laugh, but that's what a lot of metrics are like. Well, we're collecting this metric because we can do this easily. Does it have any relation to how far the product? Well, no, not really. But by golly, we've got these great pie charts and these great graphs, and we can do this. Now, Here's another book, and I think I've got this on the list of books that you can read for extra credit. This is a book that I would strongly recommend you consider getting at some point. Small book. I didn't know about this book till several years ago. I read it on a plane trip and thought, where has this been all my life? Measuring and Managing Performance in Organizations by Robert Austin. It is almost a work of philosophy and logic, but what he does is a very methodical deconstruction of the whole idea of trying to get people to perform based on metrics. He shows that he says it can work under very specific constrained conditions, otherwise it almost always fails. And he's not talking just about software, though this is published by a big software publisher, software engineering publisher. He's talking any sort of work situation. Basically, his book is all support of Weinberg's law. Almost any attempt to manage people based on metrics ends up with a distorting influence. And it becomes almost always counterproductive. Huh?
Grades are metrics, right?
Huh? Grades are metrics, yes. There you go. Now here's the challenge.
I'm supposed to think about that.
The challenge is for project metrics, you have the project start, you're somewhere currently, and you want to know how far it is to the end. Pardon me while we go through this list, because this is why I want you to understand why metrics are so hard. Why it's so hard to predict, even when you're in the middle of a project, how close you're to finishing. You have the amount of analysis that still has to occur. There's often when you're in the middle of a project, it's like, oh, well, you know, we still have to figure out how to do X. Or we do this, or we're not getting a refresh. You have the amount of invention, as per Armour, that still has to occur. Problem solving. The amount of discovery. Oh, it's going to work if we do this, and then you discover that the update method you're using is 10 times too slow. And you've kind of gone with a new approach to get that tenfold increase in speed. Your architecture, design, and your implementation to date may not be adequate for the solution. It may not be clear how much actual code still remains to be written. It may not be clear how much quality assurance still needs to be carried out to ensure that this will operate correctly. You may have external dependencies which will cause the project to be delayed. You may have issues with the talent, experience, productivity of your developers, and or you may have turnover. A key person may leave. How do you replace her? What happens? What's the time to find someone who can fill in her shoes and come up to speed? There may be business process re-engineering. Do you know what I mean when I say that? Oh, trust me, because I work with failed IT projects that are almost always in the business setting. You have people, well, let me put it this way. What if next week I said, well, BYU has junked Learning Suite, they have a whole new system out there. But you don't know how it works.
Well, they got learning suite about a week after
And
they brought it in.
And it may change. And you may find, well, wait, where is this? How does this work? How do I get to this? I can't see my grades. Why did they do it this way? Why did they make these changes? This happens in organizations all the time, particularly when an existing system is being replaced by a new system, either an off-the-shelf system or a custom system. The complexity, cohesion, and comprehensibility of the overall system. In other words, you may have 50 people working on a system and the parts don't fit together. You may have scope creep, meaning increasing requirements, conflicting requirements. The market may change. Microsoft just announced, I think yesterday, they're no longer sending push updates to Windows Phone 7. And end of life is pretty clear for Windows Phone 8 and Windows Phone 10. Yeah, Windows make phones. Yes, Windows.
This is a Windows phone.
There you go. Windows makes phones. And you have people who are dependent upon it. You know, this was Microsoft thought this was going to be a big thing. It wasn't. That happens. So what happens to, say, companies? What if I had an app company and by golly, we're going to make killer apps for Windows phones? Okay, yeah, we're out of business.
You need to get yourself a new project manager.
Now, this is my own thought. No one's actually paid me to try this out, but this is an approach I would suggest to possibly coming up or discovering useful heuristics. It's to take a number of software projects and instrument them to automatically collect various objective metrics. These can be, you know, basically anything you can think of that you can actually measure. You know, you can track the work hours, that is the time that your engineers are in there. You can track the number of meetings. You can track, you know, collect lots and lots of data. Not for predicting yet. All you're doing is collecting data. And then when you have projects that go well and projects that go bad, what you do is you start looking at those metrics and saying, which metrics seem to correlate both with the success or failure? This is actually a time-honored characteristic. My first job out of college was at General Dynamics, where I worked on several projects. One of the projects, this is of course 40 years ago, almost. Yeah, 40 years ago. That's scary. Back then we had the USSR occupying Eastern Europe. Germany was cut in half. Various countries, Hungary, Poland, Czechoslovakia, and so on, were actually under Soviet domination. And you had what you call the Iron Curtain, which was the border between Western Europe and Eastern Europe. And it was an armed standoff between the West and the East. And Russia had its tanks in Eastern Europe, so that if hostilities broke out, they could immediately invade Western Europe with their tanks. But of course, the US had satellites and spy planes up to track where the tanks were. So the Soviet Union started building plywood painted shells of tanks and putting them on trucks. And they had about as many trucks there as they had tanks. The trucks all had shells, and they would quite literally have a shell game. They would move them from place to place, and looking down via satellite and spy plane, you couldn't tell which were the trucks and which were the tanks. So you didn't know where the Soviet Union actually had its effective tank forces massed. Well, one of the engineers at General Dynamics got this idea. If you do side-looking radar, standoff radar, it's like if you bounce this off a truck or a tank, trucks have wheels, tanks have treads. The radar signal coming back from bouncing it off the sides may look different. So I worked with him on this. He went out to Camp Pendleton and did the standoff radar on trucks and tanks out there, collected a lot of data, and then I wrote code that did Bayesian analysis on, we determined 27 characteristics of the radar signal that came back. And we did Bayesian analysis, for those of you that had stat, to determine which set of characteristics best partitioned the trucks from the tanks. And we found with just 3 characteristics, we could get a 97% separation. In other words, based on this radar signal, we simply looked at 3 signals, and based on their values, we could say that's a truck or a tank with 97% accuracy.
How'd you get the Soviets to let you borrow their tanks?
We didn't. It was just tanks. It was Marine tanks up at Camp Pendleton.
Okay. What about the trucks?
But treads, you know, tires are tires, treads are treads. Yes?
Did they ever try to throw you off by mixing trucks and tanks together in the same group?
Well, this was early days. This was He was doing this as a proposal to the Pentagon to develop this and get a defense contract and so on. I did my coding at that. The point is with metrics is that what we lack is research to do this kind of thing. Run a lot of software projects, collect a wide variety of metrics, characteristics, and then see what works and what doesn't. We have some ad hoc metrics that we use and some ad hoc rules of thumb that we use. But this is, we really don't have a good way of predicting, except when you get very close to the end of saying, you know, yeah, the product's going to ship. Yes?
Well, once you find such metrics and companies start making philosophies on these metrics, then they start being measured and they start being fudged. So aren't you kind of...
No, because again, they have to be objective, repeatable, and informative. You're not rewarding people based on metrics. You're simply using it to estimate when you think the project's going to be done. That's the difference. The problem is metrics are usually used to reward or punish. And this gets back to, don't they know they're dealing with grown-ups here? Okay. Questions? Any other questions on the metrics? I trust you'll actually go read the articles.